What if you could leave Earth right now? No waiting, no turning back, just you and the stars. You rise above the clouds, past the moon, past the planets, past the edge of everything you've ever known. And then, silence. You've entered the deep void between stars. Out here, time stretches, light fades, and gravity pulls you toward the greatest mystery in our galaxy, the center. There, hidden behind a billion stars, is a supermassive black hole. A place where space falls in on itself, where time slows to nothing, and no one knows what lies beyond. This is not science fiction. This is real. This is a journey through danger, beauty, and the limits of what we understand. This is the Milky Way, and we're heading straight into its heart. Our journey to the center of the Milky Way starts right here on our pale blue planet. Earth is our home, a small world circling an ordinary star at the edge of a spiral galaxy. But today, we're not staying, we're leaving. To leave Earth, we first have to beat its gravity. Everything with mass has gravity, and Earth's pull is strong. It keeps the oceans in place, holds the moon in orbit, and keeps us on the ground. To break free from this invisible grip, we need a lot of speed. This is called escape velocity. For Earth, that's about 11.2 kilometers per second, over 40,000 kilometers per hour. Rockets have to go this fast just to leave Earth's atmosphere and reach space. The first stage of our journey isn't just about speed. It's about engineering, planning, and precision. Spacecraft are built to survive the intense heat and pressure of launch. They carry fuel, navigation systems, communication gear, and sometimes even people. Once a rocket escapes Earth's atmosphere, it enters low Earth orbit. This is where the International Space Station circles the planet and where many satellites work. But to head for the center of the galaxy, we have to go much farther. Our spacecraft needs to fire its engines again to escape Earth's orbit and the sun's pull. We have to leave the solar system itself. This takes careful planning and maybe even a boost from other planets like Jupiter to pick up extra speed. From here on, we leave everything familiar behind. The sky turns completely dark. Earth becomes a tiny, glowing dot behind us. The moon fades away. Our home system shrinks. Now we're truly in space, heading for the heart of the Milky Way. The scale of our journey is hard to imagine. The center of our galaxy is over 25,000 light-years away. With today's technology, it would take millions of years to get there. But for this documentary, we'll speed things up and fly faster than anything ever built. We're not just space travelers anymore, we're explorers of the galaxy. Our next stop, the far edges of the solar system. We've left Earth behind, and now we've passed the moon. The moon is silent, cold, and empty. There's no air, no oceans, and no wind, just craters and dust. It's been Earth's companion for billions of years, but now we say goodbye. Our journey goes on. We start moving past the planets. First is Mars, the red planet. Then we pass the giants, Jupiter and Saturn. Their swirling clouds and icy rings are beautiful, but they can also be dangerous. Farther out, we find Uranus and Neptune. These distant worlds are cold and dark. Sunlight is weak here, and temperatures drop hundreds of degrees below zero. Beyond Neptune, we reach the Kuiper Belt, a strange region full of frozen objects, chunks of ice, rock, and dust. This is where Pluto is, along with other icy worlds. Even here, we're still inside the Sun's domain. To truly leave the solar system, we have to go much farther. Eventually, we reach the edge of the Sun's influence. This invisible line is called the heliopause. Here, the solar wind, a stream of particles from the Sun, finally stops. Beyond this, we enter interstellar space. Only a few spacecraft have ever made it this far. Voyager 1 is one of them. It carries a golden record, a message from humanity. Launched in 1977, it's still traveling, but even at its incredible speed, it would take tens of thousands of years to reach another star. Space is enormous. The distances are almost impossible to imagine. Between the stars, there are no planets, no light, and no sound. There's only thin gas, dust, and endless darkness. This is called the Interstellar Medium. And now, we're in it. The Sun fades behind us. It becomes just another star in the black sky. The solar system disappears from view. Ahead is the galaxy, the Milky Way, a vast spiral of stars, gas, and mysteries. Now we're ready to explore it. Next, we'll travel through our galactic neighborhood. We are now deep in interstellar space, the vast region between the stars. It might look empty, but it isn't. The interstellar medium is filled with thin gas, tiny dust particles, and invisible radiation. Out here, it's incredibly cold, almost at absolute zero. Most of the gas is hydrogen. The dust is made of carbon, silicon, and ice. This dust is so fine like smoke that you wouldn't see it with your eyes, but it's there. This gas and dust are the raw materials for new stars. Sometimes they gather into huge clouds called nebulae. In these dark places, gravity pulls atoms together, pressure builds, and deep inside, a new star can eventually ignite. But most of interstellar space is quiet, silent, and vast. Radiation moves through this emptiness, light from distant stars, X-rays from exploding stars, and cosmic rays, which are particles traveling almost at the speed of light. This radiation can damage spacecraft and harm electronics. That's why our ship needs protection. It must be shielded and strong enough to survive the journey. Speed is another challenge. Even if we travel at tens of thousands of kilometers per hour, it's still far too slow for this trip. At that pace, it would take thousands of years to reach the center of the galaxy. In this story, we imagine something much faster, a ship that could travel a big fraction of the speed of light. That's not possible today, but maybe one day it will be. Navigation here is also tough. There are no roads or signs. Stars move, the galaxy rotates, and gravity from stars and dark matter can pull us off course. So we need advanced systems to guide us, using the stars themselves as our map. We keep moving forward. The stars are getting denser now. We're entering the heart of the Milky Way. But for now, we're still in the outer spiral arm, the quiet suburbs of our galaxy. Ahead, the stars are closer together, brighter and older. Our next stop is our galactic neighborhood, the Orion Arm. There, we'll start to understand where we truly live in this vast island of stars. We are now deep inside the Milky Way galaxy. But where are we, exactly? Our solar system sits in a small part of the galaxy called the Orion Arm. Some scientists call it the local spur. It's not one of the main spiral arms, but a smaller branch between the Sagittarius and Perseus arms. This is our galactic neighborhood. This is a quiet region, far from the busy and violent center. Here, stars are spread out and space feels calm, but there are still many wonders to discover. Some of the stars closest to us are in the Alpha Centauri system, just over 4 light-years away. It includes a small red dwarf called Proxima Centauri, which might have a planet where life could exist. Another nearby star is Sirius, the brightest star in our night sky. It looks so bright because it's close, only about 8 light-years away. Betelgeuse is another famous star. It's a red supergiant in the constellation Orion. If it were where our sun is, it would stretch far beyond Mars. One day, Betelgeuse will explode as a supernova. These nearby stars help us learn about our galaxy, but they don't stay still, they move. Every star in the Milky Way orbits the galactic center. Our sun takes about 220 million years to make one full trip. That's called a cosmic year. This slow motion shapes the Milky Way structure. Our galaxy is shaped like a disk. It's flat, wide, and spinning. Most of the stars and gas are found in this disk. This is where we see the spiral arms. The disk isn't alone. Above and below it is a halo of older stars and invisible dark matter. In the center of the disk is the bulge, a dense, round area packed with stars. Now, we start to see the bigger picture. We are just one small solar system, on a small arm, in a huge galaxy. The Milky Way stretches more than 100,000 light-years across and holds over 200 billion stars. Our journey now goes even deeper into this vast system. Next, we'll pass through clusters and nebulae, places where stars are born and where they die. Now we travel through some of the most beautiful and mysterious places in the galaxy. Here, stars are born, live their lives, and eventually die. First, we pass by star clusters. These are groups of stars that form together from the same cloud of gas and dust. There are 2 main types of clusters. Open clusters are young, with hot and bright stars. They are loosely held together by gravity and may slowly drift apart over time. One well-known example is the Pleiades, a group of blue stars about 400 light-years from Earth. Globular clusters are different. They are very old and can contain hundreds of thousands of stars packed tightly together. These ancient stars are among the oldest in the galaxy. Between these clusters, we find nebulae, huge clouds of gas and dust floating in space. Nebulae are the birthplaces of new stars. In these stellar nurseries, gravity pulls parts of the cloud together. As more material gathers, pressure builds and the center gets hotter. If the conditions are right, a new star is born. Hydrogen fuses into helium, and the star begins to shine. The Orion Nebula is one of the closest star-forming regions to Earth. It is just over 1,000 light-years away, and new stars are forming there right now. Another beautiful example is the Eagle Nebula, home to the Pillars of Creation. These tall columns of dust and gas are slowly shaped by radiation from young stars. But stars do not last forever. Small stars like our Sun live for billions of years. When they run out of fuel, they expand into red giants and then shrink into white dwarfs. Massive stars have much shorter lives. When their fuel is gone, they explode as supernovae. These powerful blasts scatter heavy elements across space, the same elements that make up planets and even life. Some of these massive stars leave behind neutron stars or black holes. In this part of the galaxy, we see the full cycle of life and death, happening over millions of years. The gas and dust from dying stars become the material for new stars. The galaxy recycles itself again and again. Our journey continues, moving deeper into the Milky Way. Ahead are the spiral arms, the sweeping structures that give our galaxy its iconic shape. We're now entering the Milky Way's grand design, its spiral arms. These arms are the galaxy's most eye-catching feature. They're huge, curved bands filled with stars, gas, and dust, wrapping around the galaxy like ribbons. The Milky Way has several main arms. Two of the biggest are called the Perseus arm and the Sagittarius arm. There are also smaller arms and spurs, like the Orion arm, where our solar system is found. But these arms aren't made of solid material. They aren't fixed in place. Instead, they're areas where stars are packed more closely together. It's like a traffic jam on a highway. Stars move in and out of the spiral arms. These crowded regions move through the galaxy as density waves, slow patterns that squeeze gas and trigger new stars to form. As the wave passes by, gas clouds collapse and create new stars. That's why the spiral arms shine with young, bright stars. Between the arms, the stars are older and the gas is thinner. These areas are dimmer and less active. The spiral arms sit inside the galactic disk, a wide, flat area that holds most of the galaxy's stars. This disk is about 100,000 light-years across, but only a few thousand light-years thick. Above and below the disk is the galactic halo. The halo is much less dense. It contains old stars, globular clusters, and maybe a lot of dark matter. At the center of the disk is a bulge, a dense, round area packed with stars. We'll get there soon. For now, we keep traveling through the arms. We pass young clusters, bright nebulae, and glowing gas. We're heading toward the crowded inner galaxy, where the spiral pattern starts to fade. As we go deeper, the space between stars shrinks. Radiation increases. The forces at work get stronger. The Milky Way isn't just a collection of stars. It's a dynamic, ever-changing system. Next, we'll explore the dangers that lie deeper within the galaxy, a region where the environment becomes even more extreme. As we get closer to the center of the Milky Way, things start to change. The stars shine brighter and are packed much closer together. Space feels crowded. This is the inner galaxy, and it's far from peaceful. Here, there are many more stars than in the outer parts of the galaxy. That means more radiation, more heat, and more danger. In this region, massive stars live fast and burn out quickly. Many of these stars end their lives in supernova explosions, some of the most powerful events in the universe. These blasts send out huge amounts of energy and scatter heavy elements across space. We also find gamma-ray bursts here. These are quick flashes of high-energy radiation that can come from collapsing stars or merging neutron stars. Just one burst can outshine an entire galaxy for a few seconds. The radiation from these events can damage spacecraft and harm living things. If one happened close to Earth, it could even strip away parts of our atmosphere. There are also rogue black holes drifting through space, left behind by supernovae. They're invisible and silent, but they bend space around them. If a ship got too close, it might never escape. Gravity here is stronger and more unpredictable. Sometimes several stars orbit each other in complex systems. Giant clouds of gas sweep through space, collapsing under their own weight to form new stars. This area is also full of cosmic dust and fast-moving particles. These can mess with sensors, communications, and power systems. Any spacecraft here needs to be built to handle extreme conditions. Navigation gets harder. Signals can be disrupted and star maps become less reliable. The environment changes quickly. Even so, this part of the galaxy is full of mysteries. The inner galaxy holds clues about how the Milky Way was formed. It has some of the oldest stars ever found, and strange objects we still don't fully understand. We're now getting close to the Galactic Bulge, the crowded, glowing heart of the Milky Way. The journey will get even more intense there. But to see what's ahead, we first have to pass through the bulge and look into the very center of our galaxy. We're getting close to the Galactic Bulge, the dense, rounded core at the center of the Milky Way. This place is unlike anything we've seen so far. The bulge holds billions of stars, all packed tightly into a space just a few thousand light-years wide. From far away, it glows like a golden sphere. But up close, it's chaotic, hot, and crowded. Many of these stars are very old, some almost as old as the galaxy itself. Their light is redder and cooler, and there are far more of them than the bright young stars we saw earlier. The gas here is different too. It's thicker, warmer, and often hidden behind huge clouds of dust. Visible light can't get through easily. That's why we use infrared and radio waves to observe this region. These can slip past the dust and show us the stars inside. The bulge is home to many kinds of stars. Some are rich in heavy elements, while others are mostly hydrogen and helium. This tells us the bulge has seen many generations of star formation, collisions, and mergers. Gravity is stronger here. The orbits of stars are less orderly. Some move in stretched out paths, others in random directions. It's a crowded dance, shaped by the pull of the whole galaxy, and by something else, something massive and hidden at the very center. That object is Sagittarius A star, a supermassive black hole. We're almost there. But before we arrive, it's important to know how we study this region from Earth. We're now looking at one of the most mysterious places in our galaxy, the center of the Milky Way. But we can't see it with our eyes. Thick clouds of gas and dust block visible light. Even the most powerful telescopes can't see through this veil. To see the center, we have to look in a different way. That's where radio and infrared telescopes help. These instruments pick up waves that pass through the dust, letting us discover what's hidden from view. One of the most important tools is the Atacama Large Millimeter Array, or ALMA. It sits high in the mountains of Chile. ALMA uses dozens of dishes working together to catch faint radio signals from space. We also use infrared telescopes, like the Spitzer Space Telescope, and X-ray telescopes in space, such as Chandra. These help us watch the high-energy activity near the center of the galaxy. There's also the Event Horizon Telescope, a worldwide network of radio telescopes working as one. In 2019, it captured the first image of a black hole's shadow in another galaxy. Now it's focused on the center of the Milky Way. Thanks to these eyes, we've seen something amazing. Stars near the center move at incredible speeds. One of them, called S2, orbits an invisible object every 16 years, racing at thousands of kilometers per second. This shows us that something very massive is hidden in a tiny space. That object is Sagittarius A star, the supermassive black hole at the heart of our galaxy. It's more than 4 million times the mass of our Sun, yet it fits inside a space smaller than Mercury's orbit. We can't see the black hole itself, but we can see how it affects the stars around it. Their motion is the strongest proof that the black hole is real. We're now getting closer. Soon, we'll witness gravity at its most extreme. We've arrived at the very center of the Milky Way. This is where Sagittarius A star is found, a supermassive black hole unlike anything else in our galaxy. We can't see it with our eyes, but we know it's here. The stars nearby move in tight, fast orbits. They're pulled by something incredibly heavy and dark. Despite its name, Sagittarius A star isn't a star at all. It's a black hole, a place where gravity is so strong, nothing can escape, not even light. This black hole has more than 4 million times the mass of our Sun, yet all that mass is squeezed into a space no bigger than our solar system. Some say it's the most extreme object in the galaxy. As we get closer, we see clouds of gas spiraling inward. These clouds are pulled toward the black hole and heated to millions of degrees. They glow in X-rays and radio waves just before they disappear forever. This glowing ring is called the accretion disk. It's the last place where light can escape. Beyond that is the event horizon, the point of no return. Here, time and space start to behave in strange ways. From far away, time seems to slow down near the event horizon. If something falls in, it appears to freeze and slowly fade into darkness. But from its own point of view, it just keeps falling. No sudden stop, just a quiet crossing of a one-way boundary. This is one of the biggest mysteries in physics. We can't see what happens inside. No signal, no light, and no information can escape. The laws of physics as we know them might break down beyond this point. Still, we're here, right at the edge, about to cross into the unknown. Next, we'll begin our descent into the black hole and explore what science thinks might happen inside. We are now crossing the event horizon of Sagittarius A star. This is the point where nothing can escape. Not a ship, not light, not even time as we know it. Once we pass this line, there's no turning back. If someone watched us from outside, they would never see us cross. To them, we'd seem to slow down, freeze, and fade away. But inside the event horizon, everything feels normal, at least for a while. Now we begin to fall inward. Gravity gets stronger with every second. Space stretches, time warps. The closer we get to the center, the more powerful these effects become. One of the strangest effects is called spaghettification. As we fall, gravity pulls harder on our feet than on our head. This difference stretches us out like spaghetti. Bones, metal, even atoms, everything would be pulled apart by these extreme forces. Nothing we know could survive this. No signal can escape. It's the deepest kind of silence. As we fall further, space itself bends in ways we can't imagine. Time might not move in a straight line anymore. Distances shrink. Directions lose their meaning. What's at the center? We don't know. Einstein's theory says we'd reach a singularity, a point of infinite density where physics breaks down. But quantum theory hints that something else happens. Some scientists think the singularity isn't real, but a sign that our understanding is incomplete. We truly don't know what comes next. There could be another side, or nothing at all. What's certain is that we've crossed a final boundary. Next, we'll explore what science and imagination can tell us about what lies inside the heart of a black hole. We are now inside the black hole. There's no turning back, no light, no escape, and no way to contact the outside universe. Here, space and time are no longer separate. The laws of physics as we know them don't work the same way. This is the heart of darkness, the unknown inside a supermassive black hole. At the center, there might be a singularity, a point where everything is squeezed into zero space. But many scientists think something else happens. The rules of quantum physics and general relativity can't both be right here. One of them must give way. Some theories say the singularity isn't real. Instead, space and time might bend into a new shape, one we don't understand yet. Some physicists imagine a black hole could be a doorway, a bridge to another universe, or maybe to a different part of our own. Others believe that information swallowed by a black hole isn't lost, it's just changed. This is the black hole information paradox, a puzzle we still haven't solved. We simply don't know what's inside. Maybe we never will. But black holes challenge everything we thought we knew. They push the limits of science and show us how much more there is to learn. And they remind us that the universe isn't just vast and powerful, it's also deeply mysterious. Our journey started on a small planet orbiting an ordinary star. We crossed the spiral arms of the Milky Way, passed through star-forming regions, ancient clusters, and powerful bursts of energy. It brought us to a black hole, silent, dark, and eternal. From the edge of Earth to the edge of physics, we've come a long way. But this isn't the end. In the search for knowledge, every answer leads to more questions. The universe still holds many secrets, waiting to be discovered.